Hello everyone, welcome to the live. Today we're going to do some A-level maths pure 1 practice for the exam on Wednesday. So this paper I chose is the October 2021 pure paper 1 because it has some trapezium rule questions and year 2 binomial expansion which did not come up in 2025 I believe, so they could likely come up this year. Okay, so let's get started with question 1. So we're given a function f of x, and we're told that given that x minus 1 is a factor of f of x, find the value of the constant a. So they're telling us to find the factor, so we need to use the factor theorem. So we know that if x minus 1 is a factor, then by the factor theorem, we know that f of 1 should give us 0. So we can use this rule. So if we have f of 1, we get a times 1 cubed, which is just a, plus 10 times 1 squared, which is plus 10, minus 3a times 1, so that's minus 3a, minus 4, and we know that's going to be equal to 0. So then we just do this arithmetic, so we do a minus 3 is minus 2a, and 10 minus 4 is plus 6, equals 0. 2a is equal to 6, and therefore a is equal to 3. And that is the value of our constant a. And you can check this by substituting it back into this and just seeing that you get that as a root. This question is part of AS, but I am going through an A-level paper. But this is in the first year of the content, so it's AS content 2. Okay, so nice. Question 1, good 3 marks, pretty standard factor theorem question. Moving on to question 2. So question 2, they give us another function. We need to express this function in the form x plus a whole squared plus b, where a and b are integers to be found. So we need to know that a and b are integers, which can help tell us if we've got the correct answer or not. And this form is the completed the square form. So all we have to do is complete the square. So you have f of x is equal to x squared minus 4x plus 5. And if we complete the square, we take the first x part and do x minus half of this one, 2 whole squared. Then you subtract this second value squared, so minus 4. And then you have the plus 5 from before. And then that's equal to x minus 2 squared, and minus 4 plus 5 is plus 1. And this is your answer, where a is equal to negative 2 and b is equal to 1. I'll explain this again. So the reason we're completing the square here is because this form here that they've given us is completed the square form, because you've got x plus something whole squared plus something else. So we take our x terms and we just take out 1x from there, and then you have this x coefficient value and you take half of that and then you square the whole thing, and when you expand this out, you have this extra 4 term which we didn't want from here, so we take away that 4. And then you have the plus 5 from before, and then you just simplify by doing negative 4 plus 5 is positive 1. And that's it. Yep, that's it for part A. So 2 marks in the bag. Now for part B, we're given some more information. This curve with equation y equals f of x, which is just this thing over here, meets the y-axis at point P. So this is about the y-intercept and has a minimum turning point at point Q. So this is, as it says, about the turning point. And then, yes, this is year 1 content. So then we need to find the coordinates of P and the coordinates of Q. So all we need to do is find the coordinates of the y-intercept. So P is my y-intercept. I like to write that out in the exam so it shows the examiner I understand what exactly I'm doing. So at the y-intercept, we know that x is going to be equal to 0 because remember, this is your y-axis, and at that point, x is equal to 0. And then if x is equal to 0, in this case, we get that y is going to be equal to 5. Because if I go up and look at my function here, sub in x equals 0, we just get this constant value for 5. So therefore, p is going to be equal to 0, 5 as my p coordinate. And then for part 2, the value of q, that's the turning point. So I'm going to use my completed the square. There's a reason they asked me to do completing the square. So all I can do is just read off my value. So if I just rewrite that down here for reference, squared plus 1, we know that q is going to be equal to 2 and 1, because if we remember, we take the value here and we change the sign, so that becomes a positive 2, and we just take the value here as it is for the y coordinate. This is because of how it works with the maximum and minimum. So here I've got a positive quadratic. So we know that the minimum value is going to be where this is equal to the smallest it can be To get that as small as possible, let's make it 0. Since we're squaring it, it can never be negative. So to get this to be 0, x has got to be 2, which is why you can see we changed the sign. And then, when x is 2, what is the smallest value for y? Well, that's 2 minus 2 squared, so that's 0 plus 1, which is just 1. That's how you get that the formal way. I like to remember this as I change the sign here and I keep the sign here, ck. So I get 2 and 1. So this is fairly standard quadratic expression, can be an AS level 2. So that's all you have to do for that nice 4 marks. Hopefully that makes sense so far. I have a math test 2 weeks into June. If you studied everything, just do practice now. Try and consolidate what you've studied by applying it, okay? That's the part where maths becomes a bit different to other subjects, because if you know everything, it's just a matter of practicing it out. Can you do an AS level paper as well? I will point out which questions are just AS level and which are A level. I don't think I'll have time to do an AS level paper as well, since this one will take 2 hours. I think AS has done one paper. I'm not sure if the other one has been done yet or not, but because I'm not keeping track of those ones. But yeah, parametric integration. I don't think this one has parametric integration, but I think we've got some parametric equations coming up later. And then no revision test on Wednesday, best way to cram, just do practice, I guess. To practice, just make sure you know the content, go through the summaries, and then do some practice questions. Look at the mark schemes and how they do the questions in the mark schemes so you know exactly what to do to get the marks. Okay, question 3. The sequence u1, u2, and so on is defined by un plus 1 equals k minus 24 divided by un. So we can see we've got a recurrence relation here. And they're telling us u1 is equal to 2 and that k is an integer. Given that u1 plus 2u2 plus u3 is equal to 0, show that this is the case, and we can see we've got an equation in terms of k's and is also equal to 0. So it looks like we have to substitute into this equation up here. So if we have, for question A, we know that u1 plus 2u2 plus u3 equals 0. We know that u1 is equal to 2. We know that u2 is going to be equal to, so this rule tells us how to get to our next term from our previous term. So k minus 24 divided by u1, which is 2, which is just simply k minus 12. And then u3 is going to be equal to k minus 24 divided by u2, which is k minus 12. So these are my 3 terms, and now all I have to do is sub them in. So I get 2 plus 2 lots of k minus 12 plus k minus 24 divided by k minus 12, and that is going to be equal to 0. And now all I have to do is just simplify this and try and get it into this form here. So I have 2 plus 2k minus 24 plus k minus 24 divided by k minus 12 is equal to 0. Simplify this out, so I get 2k plus k is 3k, 2 minus 24 is minus 22 equal minus 24 over k minus 12, and that's equal to 0. So now all I have to do is rearrange for k to get everything as like an integer. So I'm going to multiply through by k minus 12 over here. So if I multiply by k minus 12, I get 3k times by k minus 12 minus 22, k minus 12 minus 24 is equal to 0. Expand out 3k squared minus 36k minus 22k plus 264 minus 24, and that is going to be equal to 0. Now all I have to do is just simplify this, and once I simplify it, I end up getting 3k squared minus 58k plus 240 is equal to 0, exactly as I wanted in part A of the question. Can you explain it? This question is part of the A level maths, so it's year 13 content, because that's where recurrence relations comes up, so it's not too bad. But for this one, all you have to do is work out the terms of the recurrence relation like I've done here, and then substitute in to this equation up here, and then just play around with the arithmetic till you get the answer that they wanted. So that's part A. Then for part B, we need to find the value of k, and that's not too bad because we have an equation for k over here, and all we have to do is solve a quadratic. Are you doing a GCSE Maths paper 2 tomorrow? I might do a GCSE Maths paper 2 live tomorrow. Maybe A-levels, but I'll confirm on my page after this live. Okay, so all I have to do is solve for k. I'm going to use the quadratic formula. So k equals 58 plus minus square root of 58 squared minus 4 times a, which is 3, times by c, which is 240, divided by 2 times a, which is 2 times by 3. And if I put that into my calculator, I get 40 over 3, and I get 6. Now, how do I know which answer to pick? It's 2021 October. Yep. How do I know which one to pick? Well, I've been told that k is an integer. So k is going to be 6 from here. And I need to give my reason why. Therefore, k equals 6 because k is an integer. The question tells me it's an integer, so I know it's an integer. If it didn't tell me, then I wouldn't know which one to pick, but they have to tell me otherwise. Okay, cool. And the reason I wrote that was because they say give a reason for your answer. Then all we have to do is find the value of u3. So that's just a matter of substitution. So u3 is going to be equal to, I've been told it's up here, k minus 24 over k minus 12. So I know that k is 6, so that's just 6 minus 24 divided by 6 minus 12. And then I get that 6 minus 24 over negative 6. That's 6 plus 4, and that gives me 10 for my answer over there. So nice little recurrence relations with quadratic equations question for question 3. So far these marks should not be too bad. They're pretty standard type questions like the ones in the textbook. Hopefully that's making sense for everyone. Just keep that on the screen for a second before we move on to question 4. Okay, question 4 is where it starts to get a little bit longer, but it's not too bad. So the curve with the equation y equals f of x, where f of x is this thing here, has a single turning point at x equals alpha. Show that alpha is a solution of the equation this. So we need to find the turning point of this function here. So we know for part A that f of x is going to be equal to x squared plus ln of 2x squared minus 4x plus 5. And if alpha is a turning point means I have to differentiate. So I need to find the derivative of this function. So f dash of x is equal to 2x. And if I differentiate a natural logarithm, I just do plus this whole thing in the natural logarithm is going to be my denominator. So 2x squared minus 4x plus 5. And then my numerator is just going to be the derivative of whatever was in my brackets. So 2x squared differentiated gives me 4x, and minus 4x differentiated gives me minus 4, and then the constant terms disappear. So this is my f dash of x function, and I know that alpha is a solution of this equation, so it turns at f dash of x equals 0 to find my turning point. That's where my gradient is, 0. So 2x plus 4x minus 4 divided by 2x squared minus 4x plus 5 is going to be equal to 0. Now I'm going to multiply through by my denominator. So I get 2x multiplied by 2x squared minus 4x plus 5 plus 4x minus 4 is equal to 0. Expand that out, and then I'm going to simplify it through. So 2x times 2x squared is 4x cubed minus 8x squared plus 10x plus 4x minus 4 equals 0. Then I get 4x cubed minus 8x squared plus 14x, simplifying this part here, minus 4 equals 0. And then what is the answer they wanted in terms of a 2x cubed? So all I have to do is divide this whole thing through by 2, since everything is an even number. So I get 2x cubed minus 4x squared plus 7x minus 2 equals 0. And that is my answer to part A. No, this is not further maths. This is A-level maths paper. So that's how you do for part A. You need to know how to differentiate a natural logarithm, and then know that the gradient at a turning point is equal to 0, set that equal to 0, and then just solve and rearrange, not solve it, but rearrange to get it in the x form. Then they tell me that the iterative formula, xn plus 1 equals this thing over here, is used to find an approximate value for alpha. Starting with x1 equals 0.3, calculate each answer to 4 decimal places. I'm going to write 4dp over here so I know. The value of x2, then the value of x4. So this one is just an iteration question. So for B part 1, I know that x1 is equal to 0.3. x2 is going to be equal to, let me just bring the formula up, 1/7, 2 plus, and then wherever I have my xn, I substitute in my previous term. So I get 1/7 multiplied by 2 plus 4 times by 0.3 squared minus 2 times 0.3 cubed. These are where I had my xn's, and this is xn plus 1. Put that into my calculator, I get 1153 over 3500. That gives me 0.3294 to 4 decimal places. So that's my answer to part 1. And then for part 2, they need me to find x4. So x3 is going to be equal to 1/7 of 2 plus 4 times by 0.329 dot dot dot. I'm not going to write the full thing. You can just do dot dot dots in your exam as well, or write the exact answer. Minus 2 lots of 0.329 dot 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 cubed. And then for this one, I get 0.3375 and so on. This one I don't need to round it because they don't want this as an answer. They want x4. So then I just do this one more time iteratively. And in my calculator, I would put ants in place of these values here. So I don't need to keep writing out the full thing. Minus 2 times 0.337 cubed equals, and then for my x4, I get 0.3398 to 4 decimal places. And that is my answer to part B, 1 and 2. Then for part C, using a suitable interval and a suitable function that should be stated, show that alpha is equal to 0.341 to 3 decimal places. So to show a value is equal to something to a certain degree, we need to show the range using an interval and that those both values round to this 0.341. So the way I like to do this is, first we need to state our function. So I'm just going to call my function g of x, and that's equal to 2x cubed minus 4x squared plus 7x minus 2, because that's what I found earlier in the question for the solution of alpha up here. And I need to show that there is a change of sign between my interval and that my interval is continuous. So to show alpha is equal to 0.341 to 3 decimal places, I'm going to go plus minus 0.0005 and show that there's a change in sign and then prove my statement. So I've got g of 0.3405, so that's 0.0005 below the value. And that's going to give me minus 0.001305 and so on. And that's my negative value when I put that into my calculator. And then g of 0.3415, so I'm adding this amount onto 0.341. And that gives me 0.003663 and so on. And that's positive. So I'm happy here because I've got a negative value and a positive value. So I've got a change in sign. So all I have to do is write my conclusion. So therefore, since there is, and I need to state all of these points, a change in sign between 0.3405 and 0.3415, and I need to state this second point as well, f dash of x is continuous, meaning it doesn't jump, there's no vertical asymptotes. Therefore, alpha is equal to 0.341 to 3 decimal places. Why 0.0005? Because I need to show that alpha is equal to this value here when it's rounded to 3 decimal places. So I'm going to go the degree more, and I'm going to take half of that and go just a bit above and just a bit under, because those values round up and down to this value here. So I'm going to take those values and sub them into my formula over here and see what they give me. And because I get a negative and a positive, I know there's a change in sign. That means that there must be a root between these points, and that root rounds to 0.341 to 3 decimal places. No worries. So this one is a long-winded but standard iteration question combined with some differentiation at the start. So that is question 4. Moving on to question 5, I'll just keep it on the screen for a second. For iteration, you don't have to write out every step. For iteration, you don't. I would recommend doing it anyway, but obviously don't write out the full long decimal answer. Just write down enough information just to show you know what you're doing. I like to write it just to be safe, to show the examiner like I've done all of those things, because I've been told whatever you put into your calculator, just write it out, just to be safe. But if you don't have enough time, then don't waste time writing it. Just do the important parts if you're like later on in the exam. So I'm just going to keep this question on for a second before I get into it. High level maths isn't for the weak. It's fine, we got this, guys. Okay, question 5. A company made a profit of £20,000 in its first year of trading, year 1. A model for future trading predicts that the yearly profit will increase by 8% each year, so that the yearly profits will form a geometric sequence. According to the model, show that the profit for year 3 will be this value here. Nice, simple geometric sequence question. I mean, they also tell us it's a geometric sequence. So we know that so year 1 is 20,000. I like to write out my information for myself again. Then year 3 is going to be 20,000, my first term, multiplied by my increase, my rate, so R, which is 1.08, since it's a 8% increase. So it's my increase multiplier. And that's squared because we know that un is equal to ar to the n minus 1. So the nth term here is my third term is equal to the first term multiplied by my common ratio to the power of 2, since 3 minus 1 is 2. And then this gives me 23328, and therefore that's my value, 23,328. So that's my year 3 profit. I don't know why I struggled reading that number. Okay, cool. So nice standard 1 marker question. Part B, where a little problem solving comes in. Find the first year when the yearly profit will exceed £65,000. So let's just create our geometric rule. So we know that un equals ar to the n minus 1. So we know that a is 20,000 times by r, which is 1.08 to the n minus 1. And that value itself has got to be bigger than 65,000. So we need to just solve for n. So first I'm going to divide through by 20,000. So 1.08 times by to the power of n minus 1 is greater than 13 over 4. And then I need to take logs of both sides. So I'm going to take log of 1.08 of both sides, just so I can use my log law and bring this power down. So I just have n minus 1 here is greater than log to the base of 1.08 of 13 over 4. And then I'm solving for n. So n is going to be greater than this thing here again, 13 over 4 plus 1. And then that means if I put this into my calculator, I get 16.31, blah, blah, blah. So n is going to be greater than this value. So we need the first year, so we need an integer. So therefore, n is going to be equal to 17. So the year is year 17. And that is my answer to part B. So for these types of questions, find your geometric rule for your geometric sequence, and then just state that you need this to be greater than or equal to a certain threshold they give you, and solve using logs in geometric case, and then just find the first integer if it's an integer value required. And that's all you have to do for part B. This is not foundation GCSEs, this is A-level maths. Okay, part C. Find the total profit for the first 20 years of trading, giving your answer to the nearest £1,000. So I'm being told total profit, so I'm now thinking geometric series, because I'm trying to find a sum. So we know that the sum of the first 20 terms, and the general rule is a times by r to the power of n minus 1 divided by r minus 1. And the reason I've done rn minus 1 instead of 1 minus r to the n is because my ratio r is greater than 1, so I find this is easier to work with. So all I have to do is substitute in. So a is my first term, which is 20,000 as they told me. R is 1.08, n is 20, minus 1 divided by 1.08 minus 1. Put that into my calculator and I get 915,239.28 blah blah blah, and they want it to the nearest £1,000, so I'm looking here. So that's just going to be equal to 915,000 pounds because I round down since I have a 2 following left to the nearest 1,000. And that's my answer to part C. So, in my opinion, nice little geometric series and sequences question, a little bit of problem solving, but overall not too bad. This is the October 2021 paper 1, Alexander. All right, hopefully this is making sense to you all. And then I am going to move on to question 6 now. So question 6, vectors question, little 3D vectors question. So 3D vectors is at the end of year 13, but similar question could come up for year 12. They'll just not have the 3D aspect to it. So for part A, we need to find AC. So figure 1 shows a sketch of a triangle ABC. AB is this vector here and BC is this vector here. So we know that A to B gives us this and B to C gives us this. So A to C is simply going to be A to B plus B to C is like dot to dot. So A to B, I like to write this out using column vector form because it's much easier to work with. So I have -3, -4, -5 plus B to C, which is 1, 1, 4. Just make sure that you have I, J's, and K's matching up here and you don't put I, J's, and K's in your column vector form. And then all I have to do is just basic arithmetic. -3 plus 1 is -2. Then I get -3 here, and then I get -1. And then they want AC. I like to give it in the form that the question is set in, so in IJK form here. So then I'm just going to put, therefore, A to C is going to be equal to -2I -3J -K. So if you give it as this or as this, you get the mark. Just do not put I, J, and K over here because then that's wrong. It's redundant. Okay, cool. So that's part A. Now for part B, show that cos ABC is equal to 9/10. So thinking about how to go about this, I see the word cos, so I'm thinking cosine. So I'm going to think about using the cosine rule. And I'm going to check, can I use the cosine rule? So for cosine rule, I need 3 sides and 1 angle to work with. I'm trying to find an angle, so that's fine. And I need 3 side lengths. Well, I have my vector 3 side lengths there, so I can just find the lengths so I can use the cosine rule. So the cosine rule is a squared equals b squared plus c squared minus 2bc cosine of a. So I'm going to just find each of my little parts. So ab squared is going to be equal to 3 squared plus 4 squared plus 5 squared. And that's going to give me 50. And the reason I'm finding AB squared is so I can just easily substitute that 50 value in. I can find the square root just by doing square root and then squaring when I sub in. Either way is fine. Then BC squared is going to be equal to 1 squared plus 1 squared plus 4 squared, and that's going to give me 18. And then AC squared is going to be equal to 2 squared plus 3 squared plus 1 squared, and that's going to give me 14. So now I need to know which side maps to which value in my triangle. So they want cos ABC, so ABC, this is the angle. So the side opposite it is the AC length. So this is going to be the 14 length over there, square root of 14. So I know that we have 14 equals 50 plus 18, doesn't matter between my 50 and 80 which one I pick, minus 2 times by the square root of 50 because it's b, not b squared, times by the square root of 18 cos ABC. And all I have to do is manipulate this. So bringing all my constants onto one side without the roots, I have -54 is equal to -60 cos ABC. And this is looking nice because I have a multiple of 9 and a multiple of 10. So then I just have cos ABC is equal to 54 by 60, which is equal to 9 by 10. And that is exactly what they wanted me to prove. So yeah, nice question so far. Pretty standard. All we needed to do was recognize we need to use the cosine rule. That's the only challenging bit of this. But then if you unlock that, use Pythagoras, plug it in, get your answer. Nice little proof question done. And they give you the answer so you can check if you've got this 3 marks or not. Awesome. Hopefully this is making sense to everyone. We are going through this paper at a pretty good rate. We're about almost halfway through. So moving on to question 7. Question 7, I like part A of question 7. If they ever give me a circle question in expanded form, that just means you have to complete the square on x and y separately. I would be very happy if I saw this question. I think in my exam, they gave me a question where I had to do this. So I was over the moon, 3 marks. So for that one, 4 marks. For part A, we need to find the coordinates of the center of the circle and find the exact radius. So just turn this expanded form into the normal form of a circle that we know, and then just find the center, find the radius from my equation. So part A, so I have x squared minus 10x plus y squared plus 4y plus 11 equals 0. I like to just bring my x's and my y's together first. Then I'm just going to complete the square, so that's x minus 5 whole squared minus 25 plus y plus 2 squared minus 4 plus 11 equals 0. And then I'm just going to bring all my constant terms together and put them on the right side. So then I get x minus 5 squared plus y plus 2 squared minus 25 minus 4 plus 11 is negative 18. Bring that onto my right side, gives me positive 18. So then for part 1, the center is going to be equal to 5, negative 2, because remember the general form of a circle is x minus a squared plus y minus b squared equals r squared. So a and b are the center, so hence the negative sign there just means that the center coordinate of x is 5, not negative 5. Then for part 2, I need my exact radius as a simplified surd. So r squared is going to be equal to 18. So r is the square root of 18. That's not simplified, so all I have to do is simplify that. That's square root of 9 times square root of 2, which is just 3 root 2. So these are my answers, and I have 4 marks in the bag. Pretty nice question to start off with. For part B, I'm going to show you 2 ways of doing part B, just in case one way you find easier than another. So I'm going to show you the quicker, more algebraic way first, and then I'm going to show you the diagrammatic way, which took me a very long time until I realized you can just do the algebraic way to speed things up. So line L has an equation y equals 3x plus k, where k is a constant. L is a tangent to C. Tangent means meet at one point. In other words, they just touch, something like that. Find the possible values of k, giving your answer as simplified surds again. So we know that there are probably going to be multiple values of k, or there could be a range of values for k. Don't worry, stay in my live, Adela. Hopefully you won't fail. Hopefully. Okay, so we know that y equals 3x plus k. That line meets my circle x minus 5 squared plus y plus 2 squared equals 18 once. So I can use substitution and the discriminant to find out what my values of k are. So I have x squared minus 10x plus 25. I'm just expanding this out over here for my circle equation. Plus, and then I'm going to substitute in this line into y because that's what y is equal to. So 3x plus k plus 2 whole squared is equal to 18. And then I'm just going to expand this out. This question is not too bad. It's just a lot of algebraic expansion. So don't mess up on those easy steps and make silly mistakes because, trust me, those are quite unavoidable sometimes. So then you get 3x plus k whole squared plus, now let's see if I don't make a silly mistake, 4 times 3x plus k plus 4 equals 18. And I'm just going to tidy this up by expanding out and then collecting like terms. And I get x squared minus 10x plus 25 as before, plus 9x squared plus 6xk plus k squared plus 12x plus 4k minus 14 equals 0. Okay, cool. Now all I have to do is simplify this first. So then I get 10x squared plus, and then I get 6k plus 2x plus, and then I get 11 plus k squared plus 4k equals 0. And now I need to use the discriminant. So for my discriminant rule, I know that b squared minus 4ac is equal to 0 because I have a repeated real solution. Because they meet once, because it's a tangent. So this is a, this is b, and this is c. So b squared minus 4ac is 6k plus 2 squared minus 4 times a, which is 40, times by c, which is 11 plus k squared plus 4k. that's equal to 0. And all I have to do now is just solve for k. So I'm going to expand out and then simplify. So when I do all that, I get minus 4k squared minus 136k minus 436 equals 0. I've just cut out the step of expanding it. And then I want to solve this, so I can just plug this into my calculator, and I get k is equal to negative 17 plus minus 6 root 5 as a simplified surd. And that is my final answer. So find the possible values of k. Well, I've got a plus minus value, which makes sense, so I'm happy with that. And my answer is a simplified surd. So that's how you do part B. Now I'm going to show you an alternate way of doing part B that I did earlier with a diagram to show you what's actually happening. So you'll find that this diagram method is significantly longer than my little shorthand method down there. So I like to draw it out. So I have my circle, and it's not to scale obviously, but it does the main points. So I've got my circle over there with my center of 5, negative 2, and then I'm told tangent with a gradient of 3. So I have a positive gradient going up there and down there. And I can see my values of k will be here because those are my y-intercepts. So I know that a tangent meets the radius at 90 degrees, so I find the negative reciprocal. So the negative reciprocal of 3 is negative 1/3. So then I find the equation of my radius, which is y equals minus 1/3 x minus 1/3 by just using y minus y1 equals mx minus x1 and then subbing in. So we know that this equation of the radius, which is this line over here, it intersects the circle twice over here and over here. So if I find those points of intersection, then I can find the y values and then plug them into my equation up here to find what k is, knowing x and y. So it is a long-winded way, but it still works. This is not GCSE, this is A levels. So don't worry, this is not GCSE at all. So I just simply plug it into my equation as I did before, and this one is annoying because you have fractions, but it still follows the same premise. Oh, my bad, 1 second. Okay, so then once I rearrange, I get my x values over here of 25 plus minus 9 root 5 divided by 5, and then I need to find my corresponding y values by subbing into x over here. So then I get y equals these. Then we know that y is equal to 3x plus k, so rearrange for k is equal to y minus 3x, and then I just sub in my corresponding pairs of x and y coordinates, making sure they are linked up correctly, and then I get my two values of negative 17 plus minus 6 root 5 again. So although I went through it slightly fast, it did take a lot more work and a lot more manipulation than if we just did straight up algebra. So both of them will get you the marks. They are listed as alternatives in the mark scheme, but it's not so bad once you understand the general premise. Even if you decide to draw it out and then do the algebra, in my opinion, drawing it out helps you understand what you actually need to do. So that is how you do question 7. So we're about halfway through the paper now and only 38 minutes in, which is really good time. Let me just check the comments. The straight up algebra, yeah, just do the algebra. It's much easier. This is not further maths. That type of question won't come up at further maths GCSEs. More basic type of question could, like with circles, but not that one. Okay, cool. Hopefully this is making sense. Question 8 is where they start to become a lot more involved, but it is still pretty standard. This question 8, part A at least, is pretty standard in my opinion. So a scientist is studying the growth of two different populations of bacteria. I'm going to underline the word growth as well, so I know that there's going to be some sort of increase happening here. The number of bacteria, N, in the first population is modeled by this equation here, where A and K are positive constants and T is the time in hours. So I'm going to put a note here that T is in hours so I don't forget, in case the question decides to switch up halfway through from the start of the study. Given that there were 1,000 bacteria at the start of the study, so at T equals 0, we have N equals 1,000. And it took exactly 5 hours for it to double, so at T equals 5, N equals 2,000. Find a complete equation for the model. Pretty standard question. We just need to use our facts. So we have N equals A e to the K T. We have two unknowns here. Two unknowns, and my two unknowns are A and K. That means we need two equations. That's the rule. If the number of unknowns you have is the number of equations you need to find those unknowns. So we're going to use the facts they've given us. At T equals 0, we have N equals 1,000. So 1,000 equals ae to the k times 0. K times 0 is 0. Anything to the power of 0 is just 1. Therefore, a is going to be equal to 1,000. Nice. Then the second fact they've given me is that at t equals 5, 2,000, which is n, is equal to ae to the, well, I know what a is now, so I can just substitute that in straight away. 1,000 e to the k times t, which is 5, so 5k. So I'm going to divide both sides through by 1,000, so I get 2 equals e to the 5k. And then I'm going to solve for k. So I'm going to take a natural log of both sides. So ln of 2 equals 5k, because ln of e to the k is just k. And then k is going to be equal to ln 2 over 5. And I'm going to leave my answer as it is. Yeah, logs. So the reason I need to take a natural log or a logarithm in the first place is because my answer is in my power. So I need to get that down. So therefore, we know that n is going to be equal to 1,000 e to the ln of 2 over 5t. And that is my answer to part A. And that is 4 marks in the bag. Alternatively, the mark scheme says I'm allowed to use a value of ln 2 over 5 to 3 significant figures. So you can also get the mark if you put n equals 1,000 e to the 0.139 t to 3sf. I know that everything disappeared. I don't know why my iPad does that sometimes. So I'm just going to put the answer n equals 1,000 e to the ln 2 over 5t. But yeah, it's all about substitution in this question. Okay, cool. For part B, hence find the rate of increase in the number of bacteria in this population exactly 8 hours from the start of the study. Give your answer to 2 significant figures. So for part A, I have that. For B, I need to find a rate. So we need to find dn by dt. So dn by dt is going to be equal to, and I have e to, so this is basically e to the kx. So I need to do 1,000 multiplied by ln 2 over 5 times by e to the ln 2 over 5t, because remember the e to the kx, that stays the same, but you just multiply the e by the k coefficient here, and we have the 1,000 there, so that's also multiplied through 2. So this is my derivative function, and I need to find it at t equals 8 hours. So dn by dt, given that t is equal to 8, and that's going to be equal to 1,000 times by ln 2 over 5 e to the ln 2 over 5 times by 8. And that gives me 420.24 ... And they want it to 2 significant figures. That's 420 to 2 significant figures. And that is my answer to part B. So nice little part B question, little differentiation going on there, but not too complex, like not too much problem solving. For part C, we are given more information. The number of bacteria M in the second population, so now I'm talking about a different one, is modeled by this equation here, where K has a value found in part A. And T is the time in hours, okay, so no conversions happening there, from the start of the study. Given that capital T hours after the start of the study, the number of bacteria in the 2 different populations was the same, find the value of T. So they want us to find the T value, capital T value, where N equals M. So if I just write that out, formally what we're doing, so for part C, the populations are the same at time lowercase t equals capital T. Therefore, N is equal to M. So I'm just going to write out my equations and solve for T. Why did I have to differentiate for B? Because the question told me find the rate of increase in the number of bacteria. If I see the word rate, think differentiation, because a rate is a change of something. Okay, cool. So N equals M. So N is equal to 1,000 e to the ln 2 over 5t from before. And M, they told me, is 500 e times to the power of 1.4 times by kt, and k was the same thing in part A, so ln 2 over 5t. So this is what I have to solve for, and what am I solving for? T. So first, let's make life easy for ourselves. We've got 1,000 here and 500 here, so I'm going to divide both sides through by 500, so I get 2e to the ln 2 over 5t equals e to the power of 1.4 times ln 2 over 5t. I've said ln 2 over 5 a lot of times. Okay, cool. So now I want to solve for t. I'm going to divide both sides through by e to the ln 2 over 5t to bring it all onto one side to make it easier. So I have 2 equals e to the 1.4 times ln 2 over 5t divided by e to the ln 2 over 5t. And that means that I can, if I'm doing same base to a power divided by each other, that's just basically the same as doing 2 equals e, the top value's power times ln 2 over 5t minus the bottom value's power ln 2 over 5t. So this is just index laws with division. And now I can easily take logs of both sides, ln of both sides. So I have ln 2 is equal to 1.4 times ln 2 over 5t minus ln 2 over 5t. Because if I do a natural log of e to a kt, I just get k, like I said in part A. So exactly the same rules as before. And now I'm solving for t. So I'm going to factorize out my t on my left side. So the right side, on my right side, sorry. So my left side stays the same. Take out t. I have 1.4 times ln 2 over 5 minus ln 2 over 5 here. And then t is equal to ln 2 divided by that big fat thing in the brackets, 1.4 times ln 2 over 5 minus ln 2 over 5. Put that into my calculator, and I get a really nice value of 12.5 hours. And the work has disappeared again. So I'm just going to go into the solution thing that I made and show you what I wrote. There we go. So then you get a value of 12.5 hours. Why does it keep doing this? Apologies, guys. Okay, cool. So we can check our value by subbing in t equals 12.5 into n and m, and we should get 5656.85 in both. So indeed, the population at t equals 12.5 for n and m are the same. So for part C, given that actually no, yeah, that was it. There was no modeling assumption question in this. So why is n equal to m? Because they told us that the number of bacteria in the second population is m over here, and they want t hours where the number of bacteria in the two different populations was the same. So in the first population, we know that the number of bacteria is capital N, the second is capital M, so they're the same one, n equals m. Hopefully that makes sense. So there's a bit of problem solving going on there with differentiation and exponentials, but yeah. So that is question 8. In my opinion, the first of the more involved questions. No worries, Justina. So we are going to go back onto my sheet and hope things don't rub out again. Okay, next question, question 9. Question 9 is a partial fractions question, followed by a kind of long binomial expansion question. Binomial expansion did not come up in 2025 from what I've heard, so it could definitely come up in this exam season. So make sure you know how to do that. And we're going to go through it now. So I know that f of x is equal to this big fat fraction here, where x is not equal to these values. This is just a formality saying that you cannot divide the denominator through by 0. Given that it can be expressed in this form over here, find the value of b and c, and then find the value of a and show that it is 0. So for part A, I, we have 50x squared, let's bring the question up, plus 38x plus 9 divided by 5x plus 2 squared times 1 minus 2x, and that is going to be equal to a over 5x plus 2 plus b over 5x plus 2 whole squared plus c over 1 minus 2x. So I want to get our denominators to be the same, so I can just equate the numerators and forget about it. So if I multiply everything through if I collect my terms on my right side and make all the denominators the same, and then just multiply through by my denominators, I get 50x squared plus 38x plus 9 equals a multiplied by 5x plus 2 times 1 minus 2x plus b times 1 minus 2x plus c times 5x plus 2 squared. So now I've got two ways of finding what a, b, and c are, either by substitution or by equating coefficients. So I'm going to use the substitution method to find b and c, because if I've got three unknowns, and that's a lot of work to do if I'm equating coefficients, I find substitution is the easier first step, and then equating coefficients later to find the missing value. So I want to eliminate terms by setting these brackets to 0. That's how substitution works. So for the first one, I will get my pen. X is going to be equal to a half, because I want to eliminate b and a. Because if x is equal to half, I have 1 minus 2x is equal to 0, so x equals to a half. This whole bracketed thing here would be 0, so then b would go away. So then I get the left-hand side, subbing in x equals a half, I get 81 over 2 is equal to c times by 5 times a half plus 2 whole squared. 81 over 2 equals 81 over 4c, and therefore c is equal to 2. So that's my first answer. Part A is calm, part B is a bit confusing. Yeah, part A is pretty standard, part B is confusing because there's just a lot going on and a lot to remember, but I'm going to walk it through step by step broken down. Hopefully it's not too confusing by the end. Okay, so that's my c value. Now I need to find b, so I'm going to sub in x equals minus 2 over 5 to eliminate c this time, and also a. So I have 9 over 5 equals b times 1 minus 2 times negative 2 over 5, and then I get b equals 1 if I rearrange this and evaluate it through. This is not WJC, this is at Excel. I think the topics should generally be the same, but there are quite a few differences between, I think, the exam boards there. Okay, so that is for part 1 done. I found b and I found c. So for part 2, I just need to show that a is equal to 0. So they give me the answer, I just need to show it somehow. So for that one, I'm going to equate my coefficients, coefs, because it makes it a lot easier. And I'm going to equate my coefficients of x squared, because a has an x squared coefficient, b doesn't, but c does. So I just have to deal with one thing there. So on my left-hand side, I've got 50x squared, and that is going to be equal to negative 10a, because 5x times negative 2x is negative 10x squared, times by a. And then I have plus 25c, because I have 5x times 5x is 25x squared, so that's my x squared coefficient. And I know what c is, that c is equal to 2, so then that's 50 equals minus 10a plus 50, and then that is just equal to a equals 0 in the end. And that's all you have to do there, just show that a is equal to 0. So for part A, it's pretty standard partial fractions question, a bit more working to do because you've got to do substitution and equating coefficients. You can do it all in one way or the other, it just might be a bit longer. This way I find it much easier. Part B is pretty, in my opinion, pretty obnoxious. It is 7 marks, it's quite hefty, but you've got to do a lot of work. And it could come up this year because it didn't come up last year. So binomial expansion to show that in ascending powers of x, f of x is equal to p plus qx plus rx squared, where we need to find p, q, and r as simplified fractions. Did I mean to strike that out? Meant to underline it. And then we need to find the range of values of x for which this expression is valid. So the second part is a standard thing where you have the modulus of x is less than 1, and then you just rearrange that if need be. But for part 1, we have to do a lot of binomial expansions. So I'm going to rewrite my partial fractions with the known values of a, b, and c first, and then I'm going to walk it through step by step. So for part B1, just hoping this doesn't rub out, f of x is going to be equal to 1 over 5x plus 2 squared, because b is 1, plus 2 over 1 minus 2x, because c is equal to 2, and a is 0, so I'm not even going to write that out. And then if I just rewrite this in terms of a way so I can do binomial expansion by doing the negative power of the denominator, I have 5x plus 2 to the power of negative 2 plus 2 lots of 1 minus 2x to the power of negative 1. Now I need to do binomial expansion on this because I've got negative powers. I'm thinking year 2 binomial expansion, so I need to use this formula over here, that 1 plus x, and it's important that this is a 1, to the power of n is equal to 1 plus nx plus n times n minus 1 divided by 2 factorial x squared plus blah blah blah, plus, and then the general rule is n multiplied by the values lower than n up to n minus r plus 1 divided by r factorial of x times by x to the power of r, and then it's an infinite series. So that's the formula. It's just a matter of subbing into the formula, but you need to use it correctly. So we need to know how many terms are we going up to here. We need to find r, which is the x squared coefficient. So all I need to do is go up to my x squared term. So for the first one, I have 5x plus 2 to the power of negative 2. I want a 1 here. So I need to factorize that out and then rearrange, then I can use the formula. So if I do that, I have 2 multiplied by 5 by 2x plus 1, and that is all to the power of negative 2. So 2 to the power of negative 2 is 1/4, because I do the reciprocal because it's negative power, and then I just square it. And then I have times by 5 over 2x plus 1 to the power of negative 2. Nice. Now I can do my binomial expansion on this. So this matches the form of the formula that I have up here, where I've got a 1 over here. So now I need to be careful when I substitute in. So I have 1/4 of 5 over 2x plus 1, then negative 2 is equal to 1/4. And then I'm going to use square brackets so I don't get confused with what's inside and outside. So I have 1 plus n, which is negative 2, and x is 5 over 2x, plus negative 2 times negative 3 divided by 2 factorial times by 5 over 2x, all of that squared. And then I just keep going. I don't really care about what follows because I just need up to the x squared term, and I've already got that here. So then if I just evaluate what's inside my square brackets, I get 1 minus 5x plus 75 over 4x squared plus blah, blah, blah. And then I just need to multiply through by 1/4, and I have 1/4 minus 5 over 4x plus 75 over 16x squared plus blah, blah, blah. And this is my first part of the expansion done for this term up here, up to the x squared term. Now I need to expand this second part out here. So I have for part 2 times 1 minus 2x to the power of negative 1. That is going to be equal to 2 multiplied by, and this is already in a form which I like because I have a 1 here. So I have 1 plus negative 2 times by 5 over 2x plus negative 2 times negative 3 divided by 2 factorial, and then I have 5 over 2x whole squared. I am using the wrong one, apologies. Just realized, 1 second. I'm doing the top one again. Yeah, very long question, a lot of silly mistakes you can make. So minus 1 times minus 2x plus minus 1 times minus 2 divided by 2 factorial, and then minus 2x squared, and so on. I don't really care because I just need x squared terms. And that is going to be equal to 2 times 1 plus 2x plus 4x squared, pretty nice numbers, and so on. And that's equal to 2 plus 4x plus 8x squared. And that is my final bit for that part of my brackets. Okay, cool. So I've worked out this part, and I've worked out this part. Don't make silly mistakes like I just did. And then now I need to just add them together. So therefore, f of x is going to be equal to 1/4 minus 5/4 x plus 75 over 16x squared plus 2 plus 4x plus 8x squared, and so on. And all I need to do is just collect like terms and simplify this. So then I get 9 over 4 plus 11 over 4x plus 203 over 16x squared, and so on. And that is my answer, where these are P, Q, and R, respectively. Okay, pretty long binomial expansion question, annoying binomial expansion question, but nothing out of the ordinary. Let me just check the things. But the modulus of x is not less than 1, which is a need. That's for the next part. The requirement to use expansion is that the modulus of x is 1, but it's 2x. So the modulus of x, so we're going to come on to that for part 2, the range of values of x for which this expansion is valid. So good question, Nathan. Because we're using 2x in that case, we need to do, actually, I'm going to explain that now. 1 second, Aiden. So this should hopefully answer your question. So for part 2, find the range of values of x for which this expansion is valid. So the validity range always follows a similar pattern for any question you do. So validity So we know that generally is valid for the modulus of x is less than 1. So if I look at my equation 1, or my, not equation 1, but for part 1 over here, we've got 5 over 2x, not just x, as Aiden pointed out. So we need this to be 5 over 2x has to be less than 1. So whatever my coefficient of x is, that bundled with that x has to be less than 1. So therefore, if I just rearrange this for x on one side, I have the modulus of x is less than 2/5. So that is how I get my validity range there. So it still complies with this less than 1 bit, as Aiden pointed out. But for my second one, I've got two different binomial expansions going on here, and we need it to be valid for both. So I need to find what's the smallest validity range there. So my second binomial expansion is down here, and we can see here I've got 2x. So the modulus of 2x should be less than 1. Therefore, the modulus of x should be less than a half to make the x less than 1 thing still work. So literally, when you've got it into the valid form here of 1 plus minus ax, then just take that value and then the value next to x, put that into the modulus, then do less than 1, and then rearrange it there accordingly. So let me just do 2x less than 1. Therefore, x is less than a half. That's less than. So now I need both of them to be satisfied simultaneously. So I need to find the smaller of these. So therefore, to satisfy both, x, the modulus of x is less than 2/5, because need to satisfy both simultaneously. So that is how you do the binomial expansion. So you don't need to stop doing the expansion, even though it's 2x. Yeah, so you don't need to stop, because otherwise we can't actually do the expansion. We're just changing our validity so that, not changing it, but making it comply, so that instead of having x less than 1, modulus of x less than 1, we have modulus of 2x is less than 1. And then we're just saying that that means the modulus of x must be less than a half. Because if modulus of x is less than a half, then 2x will be less than 1 modulus. Yes, you can ask any questions in the chat. So the general formula is modulus of x less than 1, but you change it for the question. Yes, the general formula is the modulus of x is less than 1. That's the validity range for binomial expansions of this form. Then when you do it, if your coefficient of x is not 1, you need to factor that in. So you have to do 1 divided by your coefficient of x, just so overall the value you sub in for that ax thing is less than 1. That's how it works. Hopefully that helps. But yeah, pretty long binomial expansion question. Binomial expansion question was come up. So let's say B2 wasn't, what would you do about it? If B2 wasn't a question, I would still state the validity anyway, because it just takes like 5 seconds if you know that trick. If you just take the when it's in the valid form, take the ax and then just do x is less than the modulus of 1, modulus of x is less than 1 over a. Just do it anyway in my recommendation, just in case they give you a mark for that, but don't say. But typically you wouldn't be deducted a mark if they don't ask it, but it's very rare that they would just ask, they wouldn't ask that question. Like binomial and validity tends to always come up together, or there will be some weird proof or conclusion thing you need to derive. I am live until roughly 8 p.m. tonight, just until we finish this paper, and I think we've got 6 questions left. But yeah, we're in the peak of the paper where the questions take time. Okay, hopefully this is making sense to you so far. Practice binomial expansion questions. That would be if I was doing the exam, I would be doing that, since it didn't come up last year, which was quite shocking. So who knows what they have in store for this year with binomials, but it will be fine. It's just a matter of knowing what the formula looks like and how to use it and how the validity works. That's it. And then just know how to do partial fractions and combine it with this. Awesome. Hopefully that is making sense to everyone. The next question is a standard, I say standard, but like they love assessing this. Standard as in they like to assess this. Trigonometric question. This is year 2 trig. So I'm just going to keep this on the screen for a second. Wednesday's paper is going to be free. I hope Wednesday paper is good for you all. Which paper is this? This is the October 2021 paper 1. Okay, I'm just going to keep this on the screen for a second while I just have a little drink. And thank you everyone for liking the live and for engaging and joining. I appreciate all your support. Okay, awesome. For this question, they normally always put this at the top of a trig question. You can just ignore it. Just make sure you write down while you're working. Okay, given that 1 plus cos 2 theta plus sine 2 theta is not equal to 0, prove this thing here. That's just another formality again, saying that the denominator cannot be 0, so this question is technically possible. So we need to prove this identity here. Which side do you think is better to start with, left side or right side? It is quite obvious in this case, but sometimes it's not so obvious. So in this question, you need to decide which way are you going, from left to right or from right to left. Exactly, in the chat, I'm seeing the correct answer, left to right, because you don't want to, from tan theta, magically somehow spawn all this. Not that hard. So we're going to start from left to right. So I normally just put left-hand side to right-hand side for my remembrance. And then whenever I have a trig question, I always write out the rules before I start, just to make life so much easier. So my rules for my double angle theorems, because I got some 2 thetas here and I have a theta here. So I know that sine of 2 theta is equal to 2 sine theta cos theta. And then cos of 2 theta, and I've got several rules for that, so I state them all. So cos squared theta minus sine squared theta, which is identical to 2 cos squared theta minus 1, and that's identical to 1 minus 2 sine squared theta. Writing this out will make the question so much faster, and you'll actually find that this question is not too bad. No, this is what you're doing in 2 years. Yes, and it will be fine. Trust me, you'll love it. A-level maths was fun. I found it fun at least. That's why I'm still doing it. Okie dokie. So, my left-hand side is 1 minus cos of 2 theta plus sine of 2 theta divided by 1 plus cos of 2 theta plus sine of 2 theta. So, my goal is I want a tan theta, and I have 2 thetas here. So, I'm going to write down the 2 things I need to do. So, we see tan of theta. So, we want to turn our 2 thetas into thetas. And how are we going to do that? Use the rules I so conveniently wrote before I started. And we want sines over causes, because then that gives me tan. So I want as many sines as possible on the numerator and as many causes as possible on the denominator to give me a tan in the end. So using these 2 ideas, I will just work my way through my question. So 1 minus cos 2 theta, I need to turn that into a theta, and on top I want as many sines as possible, so I'm going to use this variation of my equation. So that's 1 minus 2 sine squared theta plus sine 2 theta is 2 sine theta cos theta, because I don't really have a choice on what to turn that into. And then that's divided by, I'm just going to put my identity sign there, 1 plus, and I have cos 2 theta. Well, I want causes on the denominator, so I'm going to use this version of my cos 2 theta equation. So then that's 2 cos squared theta minus 1, and then plus 2 sine theta cos theta. Okay, cool. Now I'm just going to expand out and simplify. So then I get 2 sine squared theta plus 2 sine theta cos theta. S is just sine, C is cos. I'm lazy like that. And then 2 cos squared theta plus 2 sine theta cos theta. I'm hoping you guys are getting happy when you see this, because this is becoming similar to something like that we like, and is pretty manageable now. So I have some sine 2 sine thetas up here, so I'm going to factorize that out on my numerator. So I've got 2 sine theta multiplied by sine theta plus cos theta divided by, and then here I've got cos theta and 2 cos theta in both, so I'm going to factorize that out on my denominator, and look, I've got sine over cos, which is being very nice, and then my 2's can cancel, so I'm getting pretty happy now. Then I've got sine theta plus cos theta. I've just switched them around, and then you've got sine theta plus cos theta over sine theta plus cos theta, so you can just cancel through. You can cancel these through, so then you just have sine theta by cos theta, and that is equal to tan theta as we wanted. So in my opinion, this trig proof was quite a nice one. This was like a fun trig proof compared to other ones that they've asked. But yeah, so the way I would do this is I would write out my rules at the start. Just you saw how much easier that made life for me. And then I just see, okay, what am I trying to get to? And then just think of the ideas you need to do to get there. Awesome. So that is part A. Hopefully that makes sense, everyone. And now we're going to move on to part B, hence solve. And it's important that we read the range of values of x in this case, 0 is less than x, which is less than 180. This big fat equation here is equal to 3 sine 2x. Obviously, we're going to have to use the fact that this equation can boil down to this over there. And then giving my answers to one decimal place where appropriate, and in big circle, I'm going to write 1 dp just so I don't make that last mistake. Okay, cool. So I know that I've got here that what's the difference between this and this? 2 theta and 4x. So I know that 2 theta is being replaced by 4x, so theta is equal to 2x. So I know that tan of theta is the same as tan of 2x is equal to 3 sine 2x, because I've just replaced the left side with the tan theta simplified and the right side stays the same. Where did the sine squared go? The sine squared, where was my sine squared? The sine squared, I factorized out sine over here because I've got 2 sine there and I've got 2 sine there. So you can see I factorized that out. So the sine times by sine gives me sine squared. That's where it went. Okay, cool. So now I just need to make sure that my range is correct. So the original range was in terms of x, but now I'm going to work with 2x. So my new range is just multiply all the values on either side of my inequality is this. So this is a very important step, which a lot of people miss out, and that will cause them to forget quite a few of the solutions. Nice. So I'm just going to rewrite the thing down here just so it's easier for us to follow. Sine 2x. Cool. All I have to do is solve this. To make this easier to solve, I've got a sine on my right side, so I'm going to try and turn this tan into sine and cos. So that's just sine 2x divided by cos 2x equals 3 sine of 2x. If I just multiply by cos, I have sine of 2x equals 3 sine 2x cos 2x. Now, you may be tempted to divide through by sine 2x. Do not do that, because then you will lose out solutions. What you have to do is bring everything onto one side and set it equal to 0, and then solve for things equal to 0, just like you solve normal algebra. So bring everything onto my left side. I have sine 2x minus 3 sine 2x cos 2x, and that's equal to 0. And now I have a multiple of sine 2x in both, so I'll factorize that out. Instead of cross-canceling, I have 1 minus 3 cos 2x, and that is equal to 0 now. So I just have to solve for two things. I know that either sine 2x is equal to 0, or 1 minus 3 cos 2x is equal to 0. And what is my range of x? It is this from before, as a reminder. And we need to make sure we're working in degrees, not radians. So make sure your calculator is in the correct mode here. So solving my left side first, I know that 2x is the inverse of sine of 0, and my solution my calculator gives me is 0, and then I just need to use the graph. Is 0, 180, and 360, 180 and 360. Look at your range here and see which values work for 2x. Sorry, that's meant to be a 2 there. So we know that 0 and 360 are outside the range because it's an exclusive range. It's not equal to there and there, but 180 works. So therefore, x is equal to 90 degrees, not 2x. They want x. So make sure you divide through at the end. Over here, we just rearrange for cos of 2x. So cos of 2x is equal to 1/3. So 2x is inverse cosine of 1/3. And I get 70.528, blah, blah, blah. And if I look at my cosine graph, I can see that there's another solution at 360 minus that. So all I have to do is do 360 minus this value here, and I get 289.47, blah, blah, blah. I'm going to save these in my calculator as A and B, so I use the exact value, so I don't have any rounding errors in the middle. Make sure you do that using the store button on your calculator, followed by the red letter above it, which you want to save it as. And then all you have to do is get x. So x is equal to half of these values here. So my first one is 35.3 degrees to one decimal place, because that's what they wanted. Or it's equal to 144.7 degrees to one decimal place, because that's what they wanted. So overall, therefore, x is equal to 35.3 degrees, 90 degrees, and 144.7 degrees to one decimal place. And that is another 4 marks secured in this exam for solving. Just check you've done the question correctly, checking one decimal place where appropriate, and your range is fine. And if we're all good, that is all you have to do there. Hopefully that makes sense, everyone. Let me just check if anyone has any questions. Nope. Awesome. Good. Cool. We are moving on to question 11. Question 11 is also another potential question topic that could come up. I don't think the trapezium rule came up in 2025. It came up in 2024, I believe, but not last year. So it could come up this year. It may not. It is a small topic, but it's a pretty significant one, it seems, by the looks of things. Okay, cool. Trapezium rule. Pretty nice question. But then part B is where we got to do a bit of work, but it's nice, in my opinion. Figure 2 shows a sketch of part of the curve with the equation y equals ln of x whole squared. The finite region R shown in figure 2 is bounded by the curve, the line, with equation x equals 2, so this line here, and then x equals 4, that line there. The table below shows the corresponding values of x and y, with the values of y given to 4 decimal places. Use the trapezium rule with all the values of y in the table to obtain an estimate for the area of R, giving your answer to 3 significant figures. So I write that out. This is A level, and this is trapezium rule. Trapezium rule is a blessing, Taz. I love trapezium rule too, because it's just about using a formula. So the formula, which is also in the formula book, which is quite helpful, is equal to a half times by the height times by the first y value plus 2 lots of all middle y values plus y to the n minus 1 plus the last y value once. The reason you've got one of this and one of this is because if I split this into trapeziums like so, this and this are only used in equations once, but all of these values in the middle are used in the equations twice, hence they appear twice in the trapezium rule formula. So all I gotta do is make sure I sub in the right numbers in. So that might be the only confusing part of a trapezium rule question. What are the coordinates though? Yeah. So you need to make sure you know what your height is. So our height, just draw out the trapeziums if it helps and do like GCSE trapezium work. So they're splitting it in like, it doesn't matter the diagram, but then like just say 2 and then 2.5 is the next one. So if I've got my trapezium like this, I've got 0.5 there. I've got my y0 and my y1. And using my area of a trapezium, that's a half. A plus b, which is y0 plus y1 times by the height. And the height is this is our horizontal height times by 0.5. So that is how I like to side note and understand what to sub incorrectly where. Okie dokie. So h is equal to 0.5. So area is equal to a half times by 0.5. And then I just have to substitute my values in. In my opinion, the only hard part is putting it into your calculator. So this is what I put into my calculator. 0.8085 plus 2 lots of 0.8396 plus 1.2069 plus 1.5694 plus 1.9218. I think those are all correct. Yep. And if you put that into your calculator, I get 2.408525, and then I write out my full answer, or as much as possible, and then I round just in case I have a rounding error. And I want it to 3 sig figs, so that's 2.41 to 3 significant figures. That is the trapezium rule. 3 markers. In my opinion, a free 3 marks if you just take your time. Make sure you understand what is what before subbing in. This is second year content. Yes, this is year 2 integration. But yeah, trapezium rule is all about just using the formula, but use that formula correctly, know what the height is, and use your calculator correctly. And it also helps to write down everything, just in case you make a calculator mistake, they can see you've done the thing correctly. Awesome, hopefully that makes sense. Part B is where we've got a bit of work, but the good thing with part B is we can actually verify our answers and check, are they correct? So got a few more questions. Let me just see. Wait, how did you get H again? There is a formula. The formula is at the top over here. And my height is my horizontal height. It's basically, the height is literally the distance between these things. That is H. So 2.5 minus 2 is 0.5. For part B, would you use ln times? Yes, exactly. That is exactly what you would do, Emmanuel. You do by parts, and that is what you do ln x, well, ln x squared times 1, not just ln x. Okay, cool. So for part B, use algebraic integration to find the exact area of R, giving your answer in this form here, where a, b, and c are integers to be found. Okay, so we need to do integration by parts. How do we know we need to do integration by parts? Well, we've got an ln, and if you ever see a log in an integration, just do it by parts and take u to be that. Would part A be an over or underestimate? So for this one, part A, oh no, because it looks identical. in my opinion, this looks like it would be an God, how to do over and underestimate. I think because this is a weird graph, they will only ask you over or underestimates on ones where you can actually find the derivatives. You check the second derivative and then check if it's over or under the graph. But for this one, they don't want it, so that one is not too bad. But we can get our exact answer and then see if our value is an over or underestimate. How do you know to do ln x squared times 1 and not ln x times ln x? Good question. Because when we use integration by parts, we don't want to have our dv by dx being the ln x. So we'll just set u to be ln x squared because we're going to find du by dx and we can differentiate ln x rather than integrate it. So if I've got ln x squared, I know I've got to do it twice in the end because I'll get rid of it once, then I need to get rid of it again. And you're going to see we're going to do by parts twice, but it's pretty standard. So I'm going to be integrating from 2 to 4 because those are the limits. No worries, Michael. Ln x whole squared with respect to x. Why? Because I've got logs, so I'm going to do it by parts. By parts. So I'm going to put the formula in blue for your reference. So integrating u dv by dx with respect to x is equal to uv minus the integral of v du by dx with respect to x. So basically, you see these two things here, they're just kind of like switched over here, and then you do uv minus that. And this formula is given in the formula book as well. So we can differentiate ln x, so we set u to be equal to ln x. So then we have du by dx is equal to, so ln x squared. So then we use the chain rule and we have 2 ln x times by 1 over x. We just multiply the whole thing by the power 2, reduce the power by 1 to get 2 ln x, and then by the chain rule times by the thing in the brackets derivative of that. So ln x differentiates to 1 over x. Then we need our dv by dx, and in this case is just 1. So then we integrate it to get our v, and that's just x. Increase the power by 1 to divide by the new power. And then all we have to do is sub into our formula. So we have 2 to 4 of ln x squared dx is equal to uv, which is x ln x squared from 4 to 2 minus 2 to 4 x 2 ln x divided by x, because that's vx times by du by dx, which is this thing over here. So I've just multiplied this thing and this thing across with respect to x. Okay, cool. So now if I just clean this up, ln x squared from 4 to 2 minus the integral from 2 to 4, these cancel. Then I just have 2 ln x with respect to x. How do I know what to set u and dv by dx? Always remember that for u, if you've got a log, that will take priority. Set that to be u because you can differentiate that. So set u to be equal to the logarithm. That is your giveaway for that. Okie dokie. Yeah, just remember the ln x, you write it as ln x times 1 exactly, then write it as ln x times 1, or in this case, ln x squared times by 1. Where 1 is my dv by dx, so that's the times by 1 there. Okay, cool. So now I've got another ln x, so we need to do by parts again. So I'm going to do u, and what do I take for u, guys? It's going to be ln x, because I can differentiate that to get 1 over x. Then dv by dx, I could have taken the 2 out, but I'm just going to keep it in and just set that to 2. And then v is going to be equal to 2x if I just integrate that over there. And then I'm going to do by parts again. So I'm just going to take this part, ignoring the left-hand side, but not forgetting it. So minus, and then I've got 2x ln x because of uv from 4 to 2 minus the integral from 2 to 4 of 2x times 1 over x with respect to x, because then that's v du by dx. And then this and this can cancel, which is quite nice because then it just leads to minus 2x ln x from 4 to 2 minus, and then I'm integrating 2. So that just becomes 2x from 4 to 2. And now I can just put everything together because I am evaluating everything from 4 to 2. So if I just put that all together, I have x times ln x squared minus 2x ln x. I don't know why I put that in brackets because I don't need those anymore. 1 second. And then I have minus and minus make a plus, so we need to do plus 2x, and that's from 4 to 2. I'm working out the integral. And then all I have to do is just sub in and evaluate and clean up. And then I need to clean up and get it into this form over here, a ln 2 whole squared plus b ln 2 plus c. So now it's all about subbing in and cleaning up. So I've got 4 ln 4 squared minus 8, sorry, ln 4 plus 8 minus 2 ln 2 squared minus 4 ln 2 plus 4. Now if I group my like terms and I clean up a bit, I've got 4 ln 4 squared minus 2 ln 2 squared minus 8 ln 4 plus 4 ln 2 plus 8 minus 4. I've just put my things together, so I've got my ln something squareds together and my ln's together and my constants together. Okay, now I need to get ln 2 in my log. So how am I going to get ln 2 in my log? I'm going to use a log law. I need to rewrite ln 4 somehow. Well, I know that ln 4 is equal to ln 2 squared, which is equal to 2 lots of ln 2 by the power log law. So I'm just going to rewrite it like that. So that's going to be equal to 4 lots of 2 ln 2 whole squared minus 2 ln 2 squared minus 8 times 2 is 16, so 16 ln 2 plus 4 ln 2, and then 8 minus 4 is 4, so plus 4. Now all I have to do is clean up. This is the nice part. So I need to do, hold on, I made a little mistake. No, I did not. Then I just need to do 16 of ln 2 squared minus 2 ln 2 squared minus 16 ln 2 plus 4 ln 2 plus 4, and that's going to be equal to 14 lots of ln 2 squared minus 12 ln 2 plus 4. And that is my answer in the form that they wanted it in. Okay, and then just check. The good thing about this question is we can check if our answer in part B is close to our answer in part A. It is correct because it should be close to our answer in part A. So if I put my 14 ln 2 squared minus 12 ln 2 plus 4 into my calculator, I do get a number that is close to 2.41, and from that I can see if it's an over or an underestimate question as well, and validate my answer. So 8 marks in the bag. So this is what you would do for part B. That the only integration part is the thing on the page, and then it's about cleaning up logs at the end. Hopefully that makes sense. Let me just check the chat. Time saying, can you do a cyclic integral question? I'm just doing the questions in this paper. I'm not gonna make up my own questions just in case they end up being obnoxious and unaccessible. This question is just about integration by parts, and you're just doing it twice, Machiavelli. So just know how to do integration by parts and set u to be the logarithm, like what it says on the screen up here. U is the log. And then this is A level. We're not doing this. Yeah, this is A levels. And this is not further. This is year 13 integration. Okay, I think Ace this is trolling in the chat. Okay, cool. Awesome. Hopefully this makes sense. Hopefully my walkthrough helped and hopefully calmed your nerves and you saw it wasn't so bad. How is v equal to x? V is equal to x because dv by dx is 1. So if you integrate 1, you get x because you increase the power of x's by 1. So x goes from x to the 0 to x to the 1. And then you divide the whole thing by the new power, which is by 1. So then you just get x. Don't forget how to do like simple integrals. Sometimes those can be the things that throw you off. Okie dokie. All I see is ln x squared. Yeah, so ln x squared because I don't want to have, so take u to be whatever ln, whatever the log thing is, the whole bit of the log. And then any non-log bit can be the bit you multiply by, which is dv by dx, because that is easier to integrate. You don't know how to, you cannot integrate the logs in A level, so this is why we do it by parts. Okay, cool. Hey, good one, Richie. 70 out of 100. Nice. Okay, cool. Question 12. I think we've got 3 more questions. There's 15 questions in the paper. We are doing decent for time. Nice. Question 12 is a only bit. Okay, yeah, exactly. I agree, Dylan. Only hard bit of the question is the simplifying at the end with knowing the log loss. Never forget your log loss. V equals x comes from the fact that you integrate dv by dx, which is 1. I am recording this live and I'll hopefully get it onto my YouTube channel by tonight, if not tomorrow. So you can go over to my YouTube if you want to rewatch any of my explanations in the questions. No worries. Awesome. Question 12. Nice little quadratics question. Okay. Figure 3 is a graph of a trajectory of a golf ball after it has been hit until it first hits the ground. The vertical height, h meters, of the ball above ground has been plotted against the horizontal distance traveled. Don't know why it flew off the screen. X meters, measured from where the ball was hit. The ball is modeled as a particle traveling in a vertical plane above horizontal ground. So we've got 3 assumptions going on there. It's a particle, we've got a vertical plane, and a horizontal ground. Those would be important for part C. Given that the ball is hit from a point on the top of the platform of a vertical height 3 meters above the ground, so we can see in the diagram 3, it reaches its maximum vertical height after traveling a horizontal distance of 90 meters. So here we know that this is the maximum height, and we know that the horizontal distance is 90 meters. And it's at a vertical height of 27 meters above ground after traveling a horizontal distance of 120 meters. So 120 is about there. We don't know, but seems fair. It's after 90. And we know that that is going to be 27. So just annotate onto your diagram the information they've given you. Given that h is modeled as a quadratic function, find h in terms of x. So all we have to do is find a quadratic function. And there are a few ways you can go about doing this. I will show you 2 of the ways. So we know that h is going to be equal to ax squared plus bx plus c because it's a quadratic, and then just use each of the facts they give you. So at x equals 0, we know that or the y-intercept, we know that h is equal to 3, therefore c is equal to 3. So from this, just write in the form ax squared plus bx plus c, exactly, and then differentiate. Yep. So then we get h is equal to ax squared plus bx plus 3. Then from this, we can differentiate this. So we get dh by dx is equal to 2ax plus b. And we know that it is at the maximum vertical height after traveling a horizontal distance at 90. The reason we differentiate it is because maximum height is the turning point. This is my turning point. So we know that that is going to be equal to 0 at 90. So dh by dx at x equals 90 is equal to 180a plus b, and that is equal to 0. So b is equal to negative 180a. Okay, nice. Now I'm going to use my third fact over here, that it is at a vertical height of 27. So h is equal to 27 at x is equal to 120. So that's my third fact. So 27 equals 14400a plus 120b plus 3. Because I have substituted, because I have got my x squared of being 120. So now I'm going to use the fact that I know that b is equal to negative 180a and sub that in here to solve for a. So I get 24 is equal to minus 7,200a, and therefore a is equal to minus 1 over 300. And I'm happy that is negative because it is this type of quadratic. It's a sad quadratic. So a negative a coefficient is exactly what I wanted. Because b is equal to negative 180a, we know that b is equal to 180 over 300, which is equal to 3/5. So therefore, my equation of the height is equal to minus 1 over 300 x squared, that's a, plus 3/5 x plus 3. And that is all I have to do for part A of the question. And that gives me 5 marks, which in my opinion is pretty generous. It's pretty nice, 5 marks for working out a quadratic. The main thing, the kind of only hard part here is to know that we need to differentiate. Why? The giveaway is maximum vertical height. And we know that at the maximum vertical height, the gradient of this curve is going to be equal to 0. So that's how we work that out. There is another way of doing it. I'm going to show you the alternative way, which is the way I did it first, and it uses the completing the square method. So let me just go down. Quite a late question. Here we go. So the alternate way of doing it is we know that it reaches the maximum height at, let me just get the thing. So it reaches the maximum height, and that's the turning point at x equals 90. So if I do completing the square, I take out my a, and then I do x plus b over 2a whole squared minus this thing squared plus 3. That's just staying on the outside. And we know it's maximum at x equals 90. So I substitute that in. So we know that 90 plus b by 2a is equal to 0. And because a is negative, that is going to be as small as it can be. And then we know that b over 2a is equal to negative 90, so b is equal to negative 180a. That's another way of working out that b equals negative 180a. And then we just continue as normal before. And then the alternative is to differentiate. So either way will get you the marks. Do whichever is easier, but they're both fine. Hopefully that makes sense to everyone. Revise paper 3. Do one topics. Papers 2 and 3, mechanics and stats are pretty, they build a lot on like what you learn in pure. So make sure you understand the pure stuff and then you can move on to that. You'll be fine, hopefully. Stats is long, but it is doable. Trust me. Like it is a lot harder than the way you build it up in your head. It's about the mindset, guys. Okay. So if you think stats is fine, then it should be fine, hopefully. Okay. Part B is pretty nice. Hence, find according to the model the maximum vertical height. I don't know why it's still in rubber mode. The maximum vertical height of the ball above ground, and then the horizontal distance traveled by the ball from when it was first hit to when it first hits the ground, giving your answer to the nearest meter. So, what are we doing next? We are watching a TikTok live stream. Okay, so for part B, we know that it's gonna rub out again. It always does this. I don't know why. 1 second. Okay, cool. Good thing I didn't actually write anything. So for part B, 1 is maximum at x equals 90. So we know that h is equal to minus 1 over 300 times by 90 squared plus 3/5 of 90 plus 3. Put that into my calculator, and then we get h max is going to be equal to 30 meters. No rounding needed. Nice. Part 2 is just solving a quadratic equation. We know that the horizontal distance is at h equals 0. So we have minus 1 by 300, not 3000, x squared plus 3/5 x is plus 3 equals 0. Then I'm just going to multiply by 300 and then and then I have minus x squared plus 180x plus 900 equals 0. Put this into my calculator and I get x is equal to 184.868 blah blah blah, or minus 4.8. We know we cannot have a negative distance, and they wanted this rounded to the nearest meter. So we have, therefore, x is going to be equal to 185 meters to the nearest meter because we round up. And that is how you do part B. Pretty nice part B, because all we have to do is just know how to use our quadratic equation and then just sub in values. Raising the grade boundaries. Yeah, the grade boundaries increase each year. Okay, cool. For part C, I want you guys to put in the chat what you guys would put for this, and let's see if you guys will get the mark. The possible effects of wind or air resistance are 2 limitations of the model. Give one other limitation of this model. So I'm just going to keep this on the screen for a second. We'll have a drink. Put what you guys would put for this answer in the chat. So for part C, you have to refer to the model. So we need to think of other limitations and use the assumptions. So they told us the ball was a particle. The dimensions of the ball exactly match this. So we need to say that the ball is not a particle, it has dimensions or it has a size. We can also say that the ball is unlikely to travel in a vertical plane because it may spin. Vertical plane means it literally doesn't move side to side as you throw it. Also, h is unlikely to be a quadratic function in terms of x, so the ball may not actually travel in a quadratic function, which is our fourth assumption. And the third assumption, and then the fourth assumption is the ground may not be horizontal, because those were the things, the modeling assumptions they gave us in the question. So basically, when you have to find limitations of the model, go according to what the modeling assumptions are. Criticize that. Here is part A again, all on the screen there. Someone's trying to focus that. Okay, cool. So that's how you do this question, building a quadratic equation. This came up in the 2024 paper. It might come up in the 2026, but I think there might be a bit of a less chance that it will come up, that you have to build one. But yeah, this type of question came up in my exam, so I had to build a quadratic equation. Okay, awesome. Moving on, we have got 3 questions left, but the last 3 questions, in my opinion, are pretty nice compared to what we just went through. So question 13 is a fun one if you like algebra. The curve C has parametric equations x equals this and y equals this in terms of t, where t is a real number. Show that all points on the circle satisfy this equation here. All points on C, satisfy this equation, which is a circle here. So all you have to do is just show that x minus 3 squared plus y squared equals 4 when you sub in these terms up here. So you have t squared plus 5 by t squared plus 1 minus 3 whole squared plus 4t by t squared plus 1 whole squared. That is going to be equal to, now I'm going to make the denominators, is 2021 a good display of questions? Although, because wasn't this a COVID paper? This was a COVID paper. I chose it because it had a binomial and some trapezium rule. Overall, I think questions are pretty decent. It is, at the moment, kind of hard to predict, but not impossible. But these are parts of my predictions for what will come up. Yep. Okie dokie. So I'm going to clean this up by making my denominator t squared plus 1 for 3. So then I have t squared plus 5 minus 3 times by t squared plus 1 all over t squared plus 1, and that is whole squared, plus, and then this thing squared is going to be 16t squared, and then divided by t squared plus 1 whole squared. I'm not going to expand it, I'm just going to keep it as it is. Nando step after exams. Okay, and then we've got to clean up our numerator here, minus 5 plus 5 minus 3t squared minus 3 divided by t squared plus 1. As you can see, this question is nothing difficult. It's just about playing with algebra. So don't make any silly mistakes when you play with this algebra. And then if I clean up the top now completely, I have 2 minus 2t divided by t squared plus 1 whole squared plus 16t squared divided by t squared plus 1 whole squared. And then if I square this whole thing, I get 4 minus 8t plus 4t to the t squared plus 4t to the power of 4. And then that's a square there. And then that's over t squared plus 1 whole squared plus 16t squared divided by t squared plus 1 squared. Now you can see why I didn't expand out my denominator. That's my tip. Don't expand out things unless you need to. So here it makes cleanup much easier because I can just put this into one fraction. So that's going to be 4t to the power of 4 plus 8t squared plus 4 once I clean up, divided by t squared plus 1 whole squared. Nice. And then I've got some more algebraic fudging around to do, so I'm going to factorize out my 4 from the top. So I've got 4 lots of t to the 4 plus 2t squared plus 1 divided by t squared plus 1 whole squared. And I should be very happy right now because this thing, when I factorize it, gives me t squared plus 1 whole squared. T squared plus 1 whole squared divided by t squared plus 1 whole squared. Even if you didn't know that by looking at it, you could just like have a guess as to what this factorizes out and then reverse engineer and say, oh yeah, this does give me this when I expand it. And then all I have to do is cancel out my 4's and then I get 4 as required. So therefore we need a conclusion. Therefore all points on C satisfy x minus 3 squared plus y squared equals 4, because when you substitute in the parametric equations of C, they do indeed give me 4. So this one, pretty nice question. It is only 3 marks, but not too bad because we're just substituting it around. Hopefully that makes sense to everyone. And we are going to swiftly move on to question 14. Given that y equals this over this, show that dy by dx equals 1 over a root x, where a is a constant to be found. This question has, in my opinion, zero problem solving involved because it is a very standard question. They tell you y is something, they want you to find dy by dx. So we know that y is equal to x minus 4 divided by 2 plus root x. I need to just know which rule I'm using when I'm differentiating. Here I'm doing something divided by something, so I'm going to use the quotient rule, which is the harder of the 3 rules, but not actually too hard. So if we've got y in the form u over v, we have dy by dx equals v du by dx minus u dv by dx. I need to write my u's and v's differently because I tend to write them identical, divided by v squared. It's like vdu divided by v squared. How is this a 14? How's this question 14? That's what I was like when I was looking at these last few questions. They look pretty standard to me, but yeah. Okay, cool. So all I need to do is sub in. So I just need to know I like to work them out separately on top first. So u equals x minus 4. So du by dx is equal to 1. V is going to be equal to 2 plus x to the half because root x is x to the half. So dv by dx is going to be equal to a half x to the minus a half. And then I'm going to substitute in. So dy by dx is going to be equal to 2 plus x to the half times by 1 minus x minus 4 times by a half x to the minus a half divided by v squared, which is 2 plus the square root of x squared. And again, I just have to fudge about with my algebra, and that's the only hard part of this question. So 2 plus root x minus a half x to the half minus 2x to the minus half here because I'm doing my index laws, multiply a half x to the minus a half times by x. So I do minus a half plus 1 to get a half, and then I'm just multiply minus 4 by a half to get minus 2. So then all I have to do, and then the denominator is 2 plus root x whole squared. Then I clean up my top, so I have 2 plus root x minus a half root x plus 2 divided by root x all over 2 plus root x squared. Now I want to get rid of these denominators on my numerator, so I'm going to multiply both by the root of x. So I get 2 root x plus x over 2, sorry, that's meant to be a plus there, plus 2 divided by root x times by 2 plus root x squared. And now I want to get rid of this 2 as a denominator, so I multiply by 2 on my top and bottom again. And then I get 4 root x plus 4 divided by 2 root x, 2 plus root x whole squared. And now what is my answer? 1 divided by a root x. So I am close to the answer. All I need to know is that, again, this can be factorized to this. So we have that square root of x plus 2 whole squared divided by 2 times root x times 2 plus root x whole squared, and cross cancel, and we have 1 over 2 root x, where a is equal to 2. Exactly the same last bit of working as the previous question. Okay, awesome. Nice. So that is the penultimate question. Very, very standard. Yep. So far, overall, it's not been a bad paper, but it's good that we've been practicing, the standard skills so we know how to use them if we approach harder questions. Question 15 is the last question, and it is a proofs question. From what I've seen, and if you guys have been doing past papers, you'll find that the last question tends to be the proof question in paper 1 or paper 2. So just know how to do all the different types of proof. This one combines, doesn't really combine, but it uses 2 proofs and is not nice. It's not a bad one. Not a nice one. It's not a bad proof. Please no proofs. The only bad proof questions, in my opinion, are proofs by contradictions, just because you need to know which part to negate. But with practice, they are all pretty standard. So with proofs, just write out as much as you can, like anything possible, and then work your way through it. Okay, so use proof by exhaustion to show that for all n which are natural numbers and that are less than or equal to 4, this is true. So we know that if n is a member of the, lowercase n is a member of the set of natural numbers, it's going to be 1, 2, 3, and so on. And we know that n is less than or equal to 4, so we know that n is equal to the set of values of 1, 2, 3, and 4. So these are all my n's. So proof by exhaustion, I need to prove using every single one of these values for n. Exactly. Proof by exhaustion is trying every single possibility. So because every single possibility here is constrained by these two requirements, these 1, 2, 3, and 4 is every single possibility. So n equals 1, we have 1 plus 1 cubed is greater than 3 to the 1, which is 8 is greater than 3. That is true. Then we have n equals 2, so that's 2 plus 1 cubed is greater than 3 squared. That is 27 is greater than 9, which is true. N equals 3, and you can see is literally the same thing. Writing out the proofs can be repetitive, but it is exactly what you need to do. Look at the 2024 last question on the proof. It is a weird one. That's the one I had to do in my exam. Don't think they had anything like that in the textbook from what I practiced, but it just involves a lot of repetitive but basic writing in that. And then I do the same thing there, and then we can see it is true in all these cases, so I need a conclusion. So if n is less than or equal to 4 and n is a natural number, then this inequality is true. This inequality holds. Awesome. Nice proof by exhaustion questions. Why couldn't n be negative? Because n is a natural number. Thank you for responding. Yep, it is restricted by natural numbers and these cannot be negative. So natural numbers, n is the natural numbers. Natural numbers. And that means n includes the set from 1, 2, 3, and so on. Those are the numbers in the natural numbers set. Okay, cool. It is an underrated thing to know what n means, like capital N here and big Z and big R. So make sure you know what the big R, big Z means. Z are all integers, so they can be negatives. And the big R are all real numbers, so they can be anything that is not irrational, all rational numbers. Okay, cool. So for part 2, sorry, real numbers are include irrational numbers. Q are all rational numbers. My bad. Is 0 a natural number? The thing is that comes down to debate. In the mark scheme for this, they say to ignore 0, so they allow you if you've evaluated it for 0 or not. But 0 technically, like, it depends on how you interpret what positive means, and it's like a long-term mathematical debate. In this case, and like 0 can or cannot be included, you can do it both ways. The mark scheme allows it, but you don't need to in this one. Proof by exhausting, exactly, you're exhausting every single possibility. Yep. Oh, playing Valorant this time. Okay, cool. For part 2, given that m cubed plus 5, why am I sliding off? Given that m cubed plus 5 is odd, use proof by contradiction to show using algebra that m is even. So I like to write out my little thing at the start. Just trying to make you. Don't let him. Okay, so the statement in shorter terms is if m cubed plus 5 is odd, then m is even. That's what they've told me, and I need to prove this by contradiction. So we need to state our assumption first. So assumption, let's assume, there's a lot of writing and proofs, that m is odd. Because they're telling me if this is odd, then m has got to be even. Well, let's just say that no. Let's just say m is odd and try and show that this is a contradiction, then indeed m has got to be even. So if m is odd, let m be equal to 2n plus 1, because this is for odd numbers. This is how I show an odd number. 2n plus 1, it could even be 2p plus 1, or so on and so forth. So you just need to show that it's an even. Plus or minus 1, you can do plus minus here, but I'm choosing to do plus. So then I have, so m cubed plus 5 equals 2n plus 1 cubed plus 5, and I'm going to use binomial expansion. So then that's 8n cubed plus 12n squared plus 6n plus 1 plus 5. So that's by binomial expansion. You can expand the triple brackets however you want. And then if I collect my like terms, which is just the last part, I tidy it up. 6n plus 6. And then I need to show a contradiction. In other words, I need to show that m cubed plus 5 is even, not odd. I need to show this is not true. So I can factorize out a 2 here. So then I have 4n cubed plus 6n squared plus 3n plus 3. And then this is a multiple of 2. Is a multiple of 2, therefore even. You need to show that it's even, and you need to show you understand that it's even. So therefore, this is a contradiction. Cool, we found our contradiction. Now we need to actually state our conclusion. So this is a contradiction because m cubed plus 5 is meant to be odd, is odd. So then you state the original line. Therefore, if m cubed plus 5 is odd, then because we've shown that if it's m is even, we're not going to get this to be odd, then m must be even. And that is a wrap on the paper with a little proof by contradiction question at the end.